Hey y'all, I hope you're feeling happy and blessed. Before we get into factoring binomials, let's throw it back to when we first learned about fractions and we were introduced to this term, GCF, which we know stands for greatest common factor. For example, if we had the numbers 4 and 10 and we wanted to find their GCF, we could first come up with a list of each of their factors. The factors of 4 are 1, 2, and 4. The factors of 10 are 1, 2, 5, and 10, because 1 times 10 is 10 and 2 times 5 is 10. Now, to find the greatest common factor, if we break down those words, greatest means the largest one, common means they both have it, and factor, well, these are the factors. So let's compare the lists. If we look, we see that both lists have the number 1 and the number 2. The GCF would be the greater of these, which is 2. So the GCF of 4 and 10 is 2. Let's do it again. Say we have the numbers 8 and 24. The factors of 8 are 1, 2, 4, and 8, because 1 times 8 is 8, and then 2 times 4 is 8. The factors of 24, let's see. We know 1 and 24, 2 and 12, also 3 times 8, and finally we have 4 times 6. So the factors of 24 are 1, 2, 3, 4, 6, 8, 12, and 24. Remember, we're looking for the greatest common factor. So first, let's see which factors 8 and 24 have in common. So we're looking for a number that appears in both lists. Once again, they have the number 1 in common, also 2, 4, and 8. If you notice, every number will have the common factor of 1, but that's not very useful. Remember, we're looking for the greatest common factor, which in this case would be the greatest of 1, 2, 4, or 8. So the greatest common factor of 8 and 24 is 8. Important that we're very good at finding the greatest common factor, as that will help us with factoring binomials. Let's get started. The instructions here would be factor completely. The instructions could also say write in factored form. Both of these mean the same thing. If we look at number 1, we have 7g plus 5. Let's take the numbers 7 and 5 and think about what their greatest common factor is. In this case, 7 and 5 have no factors in common except for 1. Both 7 and 5 are prime numbers, which means that their only factors are 1 in itself. For example, the only factors of 7 are 7 and 1. The only factors of 5 are 5 and 1. That's what makes 7 and 5 prime. Since 7 and 5 have no factors in common, that means that 7g plus 5 is already in factored form, and that would be our final answer. So we got off kind of easy with that one. With number 2, we have 8x plus 24. Now, if you remember, we just looked at these numbers, 8 and 24. The GCF of these is 8. So when we're factoring a binomial, the first step is to find the greatest common factor of the numbers. Once we do that, we take the greatest common factor and we pull it out to the front. Then we open up a parentheses, and now we ask ourselves 8 times what will give us 8x? Well, 8 times x is 8x, so we would write down an x over here. Next, we ask ourselves 8 times what is 24? 8 times 3 is 24, so we write down a plus 3. This would be our answer in factored form. Now, you might be curious to see whether this is even correct. How would you be able to check your work? You would do so by using the distributive property. So we have 8 times x plus 3, that's the answer that we got above, and we're going to distribute the 8. We multiply 8 times x and we get 8x. We multiply 8 times 3 and we get positive 24. Now, if we take a look at our answer and we compare it to our original question up here, we see that they're exactly the same, which means we factored correctly. Notice that distribution is the opposite of factoring. I want to take this opportunity to highlight the importance of finding the greatest common factor in the first step. Remember that 8 and 24 had quite a few factors in common. They had 2, 4, and 8 in common, as well as 1, but we already know that 1 is not that useful as a common factor. Say that when you first did this question, you thought to yourself that the greatest common factor of 8 and 24 is actually 2, which we know is incorrect, but let's just pretend. So say you pulled out a 2, and then you asked yourself, well, 8x divided by 2 is 4x, and 24 divided by 2 is 12. So your answer looks like this. If we take the time to check our answer, and we use distribution to open this parentheses back up, we would have 2 times 4x is 8x, and then 2 times 12 is a positive 24, which is our original question. They match. However, this is not in factored form. And there's something you can look for here to make sure that your answer is in factored form. If you look inside your parentheses and you look at the 4 and you look at the 12 and you think to yourself, do these numbers have any factors in common? You will see that yes, they do have factors in common. The factors of 4 are 1, 2, and 4. The factors of 12 are 1, 2, 3, 4, 6, and 12. So they do have factors in common. Notice the 2 in both lists and the 4 in both lists. Since inside the parentheses, the terms still have a factor in common, that means you have not fully factored the expression and it is incorrect. In fact, an answer like this one would be an excellent trick answer in a multiple choice question. Because we see that this expression is equivalent to our question, it is not fully in factored form. The only correct answer here would be the one we got up here, 8x plus 3. Let's move on to number 3. We have negative 15 plus 10y. We know the greatest common factor here is 5. So we can pull out a 5 to the front, and then we ask ourselves, 5 times what is negative 15? Well, we know that 5 times 3 is 15, but we want our answer to be negative. So a positive 5 times a negative 3 is what's going to give us that negative 15 that we want. Next, we ask ourselves, 5 times what will give us 10y? We know that 5 times 2 is 10, so we'd write down 2 plus 2y. And this would be our final answer. Let's check real quick. If we look inside the parentheses, we have a negative 3 and a 2. The only factors of 3 are 1 and 3. The only factors of 2 are 1 and 2. Remember, every number will have the number 1 as a factor, but that's not useful when we're factoring. So, since 3 and 2 have no factors in common, we know that our answer is in factored form. And once again, we'll check using distribution. So 5 times negative 3 plus 2y. Let's see what we get. 5 times negative 3, that gives you negative 15. 5 times 2y gives you plus 10y. And if we compare, this is exactly our original. So we know we did it correctly. Now for this question, I'm also going to show you a different way you could have gone about it. The greatest common factor of 15 and 10 is 5, that is true. However, notice that the first term in this expression is negative. So maybe we want to pull out a negative 5 as the greatest common factor instead of a 5. We open up our parentheses, and here's another way you can think about factoring. Factoring is related to the operation of division. So you can ask yourself, negative 15 divided by negative 5 is what? The answer here is 3. Then you would ask yourself, 10y divided by negative 5 is what? Well, 10 divided by negative 5 is negative 2, so here we would write down negative 2y. We can check to see if we did this correctly. Negative 5 times 3 minus 2y. Again, we use the distributive property. Negative 5 times 3, that gives you negative 15. Negative 5 times negative 2y. Remember, a negative times a negative is a positive, so we write down plus 10y. Once again, if we compare this to the original question, they are exactly the same, meaning that this answer is also correct, and both answers are in factored form. Now, I want you guys to notice something very special that's happening here, and it's actually a nice little trick you can use to figure out if expressions are equivalent. If we look at these two expressions, our two answers, one with a factor of 5, one with the factor of negative 5, we'll see that both expressions have the same numbers. We have a 5 here and a 5 here. We have a 3 here and a 3 here. We have a 2 here, a 2y, and we have a 2y here. The difference between both expressions are the signs. Notice here we have a positive 5. whereas here we have a negative 5. Here we have a negative 3, whereas here we have a positive 3. Here we have a positive 2y, while here we have a negative 2y. So the signs of both expressions are exactly opposite. And that's a quick trick you can use when you want to quickly figure out if two expressions are equivalent. Moving on to number 4, we have negative 18f minus 30. Same as always, we begin by considering the greatest common factor of the two numbers here, in this case 18 and 30. If you want to test yourself on finding greatest common factors, now would be a good time to pause the video and try it for yourself. And once you do that, you'll see that the greatest common factor of 18 and 30 is 6. Now if we look at our expression here, both terms are negative. So what we'll do is that instead of pulling out a lonely 6 to the front as the greatest common factor, we'll pull out a negative 6, and that'll make our answer look a little neater. So we write down negative 6, open up a parentheses, and then we ask ourselves, negative 6 times what is negative 18f? That would be a positive 3f. Remember, a negative times a positive will give you a negative, which is what we want. Then you ask yourself, negative 6 times what is negative 30? Well, we know that 6 times 5 is 30, so negative 6 times positive 5 will give us negative 30. That leaves our answer as negative 6 times 3f plus 5. As the good mathematicians that we are, we'll take the time to check. Negative 6 times 3f plus 5. Negative 6 times 3f is negative 18f. Negative 6 times positive 5, that's negative 30. Let's compare. This is exactly the same as our original question, so we know that our answer is correct. Now, just out of curiosity, let's see what would have happened if we pulled out a positive 6 instead. How would that change our answer? So again, the greatest common factor of 18 and 30 is still 6. We'll write down a positive 6 instead of a negative 6 like we did before. Get those parentheses going. And remember, the other way you can think about factoring is as division. We can ask ourselves here, negative 18f divided by 6 gives us what? The answer here would be negative 3f. Next, we ask ourselves, negative 30 divided by 6 gives us what? And that would be a negative 5. We can close our parentheses since we have no more terms there. And that leaves us with this as our answer. If we quickly check once more, we can see that 6 times negative 3f would be negative 18f. And 6 times negative 5 gives us negative 30. This is, again, exactly our original, meaning that these two answers are equivalent expressions. And since when we look inside the parentheses, we see that 3 and 5 are both prime numbers, and their greatest common factor is 1, that means that they have no other factors in common. Both of our expressions are in factored form. If we look at them just like before, the signs are exactly opposite. Negative here, positive 3, negative 3 down here, positive 5 up here, negative 5 down here. And that also lets us know that these expressions are equivalent. In this case, both answers would be correct and both would be fair game in a multiple choice question. Now let's get tricky. These questions are different than the previous ones because here we see that both terms have an x in them. So that's going to change what we do just a tiny bit. We begin by first finding the greatest common factor of the coefficients, which are 2 and 10. The greatest common factor of 2 and 10 is 2. But wait a moment. We should also notice that both terms have x's in common. What I'm going to do is rewrite this expression in a different way. But first, we have to remember what an exponent means. Here, for example, we see that we have an x to the power of 3. Remember, what that means is that you're multiplying x to itself 3 times. That's x times x times x. Given that, I can rewrite this expression as 2 times x times x times x plus, instead of writing 10, I'm going to write 2 times 5 times x. Now, I wrote it this way to help you visualize what's really happening when we factor. Factoring means we take out what both terms have in common. This term and this term. Remember, terms are separated by addition and subtraction. Here we have a 2 in common, and we have exactly one x in common, and no more than that. So the greatest common factor for this expression is not just a 2, but rather a 2x. Same as before, we'll pull out the greatest common factor to the front. We can open up our parentheses. We'll use our visualization here to finish writing the rest of this expression. Once we pull out a 2x from the first term, we're left with x times x, which can also be written as x squared. Once we pull out 2x from the second term, we're left with just a 5, and notice that it was positive. So we can write down plus 5 over here. Now, I know I solved this question a little bit differently than all the others, and I used this weird expression here to do it, but just bear with me. You don't have to write this every time. It's more of a mental picture you can have if it helps you. But as always, if you want to write it down, do it. Now let's check our answer to see if we did it correctly. 2x times x squared plus 5. And guess what we'll use? Distribution. So we'll multiply 2x times x squared, which gives us 2x cubed. Now, why is that? Remember your properties of exponents. One of our properties of exponents says that when you multiply two terms with the same base, what you do is add the exponents. So for example, if you have x cubed times x to the fifth, notice the operation is multiplication. So what you do is that you add the 3 and the 5 and you get 8. That's what we used here. The invisible exponent we cannot see on the x here is a 1, and we add that to the 2 and we get the exponent of 3. We can keep going with our distribution and we multiply 2x times 5, which gives us plus 10. Don't forget the x. If we compare this to our original expression, both are exactly the same. So our answer is correct. This is in factored form. Let's do that again. For number 6, we have negative 3y to the 6th power minus 5y to the 4th power. We're looking for the greatest common factor. But if you notice, 3 and 5 have no factors in common except for 1. Also notice that both terms have the variable y in it. The first term, we can think of it as having 6 y's. The second term, we can think of it as having 4 y's. That means that both terms have 4 y's in common. So the greatest common factor in this case would be y to the 4th power. Also notice that both terms are negative. So just like we did in example number 4, we'll pull out the greatest common factor and make it negative. So in the front, we'll write negative y to the 4th power. And we open up our parentheses. Here we go. The coefficient here, though we cannot see it, is an invisible 1. And it's negative because we see that we have that negative there. So the question here really is, negative 1 times what is negative 3? The answer there is 3. And then we have to see how many y's we're missing. The first term started off with 6 y's. We pulled out 4 y's, so we're left with 2 y's. The next question is negative 1 times what will give you negative 5. Negative 1 times a positive 5 will give you negative 5. And to figure out how many y's we need, we see that the second term had 4 y's. We pulled out 4 y's, so there's no need to write any extra y's down to go with the 5. Leaving us with our answer being negative y to the 4 times 3y squared plus 5. Let's see if we did it right. Negative y to the 4th power times 3y squared plus 5. We'll distribute. Here we'll multiply these two terms. Remember the number here is 1. And here we have a 3. So a negative 1 times a positive 3 gives you negative 3. And then a y to the 4 times a y to the 2nd power. Remember when you're multiplying, you add the exponents. 4 plus 2 is 6. So that's our first term. Then we multiply negative y to the 4th power times 5, and that would simply be negative 1 times 5, which is negative 5, and then y to the 4th. When we compare, this is exactly our original, so we know that we factored correctly. Here's our final question for today. Negative 9m to the 5th power plus 12m squared. We'll start by considering the greatest common factor of these two terms, and the greatest common factor of 9 and 12 is 3. But remember, we also want to consider how many m's both terms have in common. The first one has 5 m's, the second one has 2 m's, meaning both have 2 m's in common, or m squared. The greatest common factor here is 3m squared. So we pull it out to the front, open up our parentheses, and we ask ourselves, 3m squared times what is negative 9m to the 5th power? Well, we know that 3 times negative 3 will give us negative 9, so we can write down negative 3. And here, we know we want to have 5 m's. We already took out 2, so how many are we missing? That'd be 3. M to the power of 3. Next, we ask ourselves 3m squared times what is 12m squared? Well, we know that 3 times 4 is 12, so we can write down a positive 4. And we wanted to say m squared, but we already have that m squared outside there, so there's no need to add any more m's to the second term. We'll check here as usual. 3m squared times negative 3m cubed plus 4. We multiply 3m squared times negative 3m cubed. Well, 3 times negative 3 is negative 9. Then m squared times m cubed, remember we add the exponents, that would be m to the 2 plus 3, which is 5. Next we multiply 3m squared times 4. 3 times 4 is 12, and just bring down that m squared with it. Let's look at our answer here, and let's look at the original. There we go, we have a match, so we know that we factored this correctly. And that's it for this lesson. I hope that was helpful.